All right, so now on your sheet, displacement, velocity, acceleration questions, I asked you to do numbers 13 to 17 on the back. So 13 says, the driver of a car going 90 kilometers per hour suddenly sees the lights of a barrier 40 meters ahead. It takes the driver 0.75 seconds before applying the brakes, and the average acceleration during braking is negative 10 meters per second squared. Will the driver hit the barrier? Okay, so there's two parts to this question. Part one is his reaction time, so he's driving along and sees this barrier and doesn't hit the brakes, so this is reaction time. And then there's this section where he actually hits the brakes and slows down. Okay? So what do we know about his reaction time? It says he's going 90 kilometers per hour. And you need to switch that to meters per second. So over here on the side, 90 kilometers per hour times the kilometers have to go on the bottom, 1,000 meters on the top, hour on the top, 3,600 seconds on the bottom. You should get 25 meters per second squared. And once you get good at this, you might realize that that's the same as multiplying by 10 and dividing by 36, or the same as dividing by 3.6. Okay, but I haven't showed you that yet because too many of you keep screwing up the long way. Okay, so 25 meters per second. And it says it takes him 0.75 of a second, so that's his reaction time. 0.75 of a second. Okay, and then he hits the brakes. So when he hits the brakes, now he's in the slowing down side part. So the VI here will also be 25 meters per second because that's what he was going before he hit the brakes. It says he slows down at a rate of negative 10 meters per second squared. That's his acceleration. And he slows down until he stops. So what you want to find is how far did he travel for his reaction time, and then how far did he travel over here while he was actually stopping. Add them together, and if it's bigger than 40 meters, he's in trouble. Okay, so for reaction time, we can use our equation VAV is equal to delta D over delta T. Rearrange for delta D, multiply both sides by time, VAV times delta T. So delta D of his reaction is 25 meters per second times 0.75 seconds. So you should get a delta D1 of 18.75 meters. So this is how far he goes before he steps on the brakes. All right, over here we have a VF, a VI, an A, and we want a delta D. So you use VF squared is equal to VI squared plus 2A delta D, and rearrange for delta D. So first, to get the delta D alone, subtract the VI squared, and then divide by the 2A. Okay, so we'll have delta D2 equals VF squared actually goes to 0. So subtract 25 meters per second, and remember that's squared, over 2 times negative 10. So on the top it's going to be negative 625 meters squared per second squared, and on the bottom it's going to be negative 20 meters per second squared. So you get a delta D2 of 31.25 meters. Okay, add these together to find out how far does he go in total. So D1 plus D2, delta T total is going to equal 50 meters. The barrier was 40 meters away, so then you would say, yes, he hits the barrier. Okay, moral of the story, don't be distracted. 0.75 is a long reaction time when you're going 90 kilometers per hour. All right, that was number 13. Number 14, just trying to find the edge of my page here. 14 says, a car moving with a constant acceleration covers a distance between 2 points 60 meters apart in 6 seconds, okay? So here's one point, here's the other point. It says the delta D here is 60 meters. It says he covers it, delta T, in 6 seconds. if its velocity as it passes the second point, the VF here, is 15 meters per second, what speed is the first point? What is the VI? Okay, well, from our delta D and our delta T, we can get our VAV, because we know V average is equal to delta D over delta T. So 60 meters over 6 seconds, our average velocity is 10 meters per second. Now, we also know average anything. If you want to find the average of two grades, you just add them together and divide by 2. So we could do the same thing with two speeds. We could add them together and divide by 2 to get our average speed. So we know the average, we know VF, we want VI. So multiply by 2 to get it off the bottom. 2 VAV is equal to VI plus VF. And now subtract VF from both sides. And that will give you VI. So VI will equal 2 times that 10 meters per second you just found, minus the 15 meters per second they gave you in the question. 20 minus 15, VI must be 5 meters per second. Okay? B says, what is the constant acceleration? Well, now that we have VF and VI in T, we can find A. It's just equal to VF minus VI over delta T. So A is equal to 15 meters per second minus 5 meters per second, and it told us 6 seconds. So that's 10 over 6. So A should be equal to 1.6 repeating meters per second squared. All right, and C says, how far behind the first point was the car at rest, assuming it had the same acceleration in that section? So somewhere back here, the original VI was 0. And it wants to know what's this delta D. So we know this VI that we found, which was 5 meters per second, really it becomes now our VF. Okay, so what do we know? We know our original VI was 0, the beginning. Our new VF is 5 meters per second, and our A is 1.6 repeating meters per second squared, and it wants to know how far behind delta D. Okay, no time given here, so use your VF squared equation. VF squared equals VI squared plus 2A delta D. The VI is 0, and you're looking for delta D, so divide by 2A. So delta D equals VF squared divided by 2A. So delta D equals VF was 5 meters per second squared divided by 2 times 1.6 repeating meters per second squared, which is like 5 over 3, so 10 over 3, 75 over 3, 25? No, 7.5. Oh, that's 25. 25, yeah, sorry. 7.5 meters is what it should work out to be. 25, 12 and a half, 5 over 3, yeah. All right, that's number 14. Number 15 says, as the traffic light turns green, a waiting car starts with a constant acceleration. So we have a car, and it's waiting, so VI is 0. And it starts with a constant acceleration of 6 meters per second squared. At the instant the car begins to accelerate, a truck with a constant velocity, so this is going to look like the jogger and the dog, a truck with a constant velocity of 21 meters per second, so VAV equals 21 meters per second, passes in the next lane. How far before the car overtakes the truck? So it's exactly the same as 1 or 2 we've already done. Okay, so here's the truck, here's the car. In the end, when the car catches up, the 2 delta D's will have to be equal. Okay, and the 2 times will be equal. So we don't know what this time is, but whatever it is, this one is the same. And we can get an expression for this delta D. It's going to be VI delta T plus 1/2 A